Welcome. So we're going to do just one graph on this Neuropod, and it is y equals negative 1/2 sine 1/4 x minus 1. All right, so let's go through the steps. All right, so first of all, though, you want to draw a table for your values. It's a 6x6 table. In the first row are the labels. So we have x, and then sometimes we change x with the period change. Sometimes we change it further with a phase shift. And then we have y. Sometimes we change y with an amplitude change. And sometimes we change it further with a vertical shift. All right, so step one, let's factor out b, except nothing, factor out. All right, so if b is in parentheses, then we'll have something to factor out. Here we do not. That's not an A. Identify the amplitude. All right, so the amplitude is the coefficient in front. Right, and in your notes you can write A equals 1/2. Is there a negative there? No, that's negative 1. A still equals 1/2. Notice there's a negative there. I almost didn't notice it. Kind of blends into the equal sign. So that negative doesn't mean your amplitude is negative. It means in addition the graph is reflected. So add that to your notes that the graph is reflected. I'm going to put it up here, I guess. And we're only dealing with reflections over the x-axis, right? So if it's in front, it's a reflection over the x-axis. All right, next you need to find the period. All right, so now let's find the period. So to find the period, we'll identify b. b is the coefficient in front of x, so b is 1/4. All right, to find the period, you take 2 pi and divide by b, so that's 2 pi divided by 1/4. I'm using up way too much space here. That's the same as 2 pi times 4, so our period is 8 pi. There's our period. So add that to your notes. So you don't need to write the NA, but do write that the amplitude is 1/2, and do write how to find the period and that it is 8 pi. Phase shift, all right, well, there is none because nothing is added to x. But what about a vertical shift? All right, so the vertical shift is -1, so we're shifted down 1. So that's a -1. So as pauses, by the way, are so that I can get the question in, and you can answer it on your pod, and then we can go over it. All right, so we didn't have to factor out b, so that's done. We have identified the amplitude, the period, the phase shift, and the vertical shift. That's done. All right, let's put the 5 key points in our graph, on our table, excuse me. So number, it is for the x values, it is the quad angles, and so that would be 0, pi halves, pi, 3 pi halves, and 2 pi, those angles that are on the x or y axes. And this is sine, right? And so, right, we've gone over the values, so when sine, and I'll just, so when we are at 0, sine is 0. When we are at pi halves, sine is 1. When we are at pi, it's the point -1, 0. Remember, sine uses the y values on the points on the unit circle. So sine is 0. Here we are at 3 pi halves. This is the point 0, -1. So sine is -1. And then we're right back to where we started from because 2 pi and 0 are the same location. They are coterminal angles. All right, so there we have our x and y values. All right, so now we need to adjust with period, phase shift, amplitude, and vertical shift. Now let's cross off anything we don't need. All right, so we had an amplitude change, we have a period change, we don't have a phase shift. So let's just cross that out. So just put an X under phase shift because we don't need it. All right, and we need the vertical shift. All right, so we've identified the 5 key points. All right, so now we need to transform X using by changing the period. To do that, we're going to take the period and divide by 4 to get the new X values. So that would be 8 pi divided by 4 is 2 pi. So we're counting by 2 pi. And you can add that to your notes. All right, so we start at 0, and then we just count by 2 pi. The last value will be the period. All right, so 8 pi should be the last value because that's the period. So we start at 0, and then if you add 2 pi, you got 2 pi. And 2 pi plus 2 pi is 4 pi. And 4 pi plus 2 pi is 6 pi. And you see if we added 2 more, 6 plus 2 is 8. So there we go. There's our new values for our period. And since there's no phase shift, these are the X values for our graph. Now let's go to the Y values. So we've already done step 5 because there was nothing to do. There's no phase shift. All right, so now we're going to multiply the Y values by the amplitude. The amplitude is 1/2. But also take care, so this is going to be amplitude and reflection. So above, just put in reflection. Reflection and amplitude. So we'll take care of both things at the same time. So instead of multiplying by 1/2, we're going to multiply by -1/2. Because our values are going to be the opposite, because we're reflecting over the x-axis. And they're going to be half as much. So 0 times 1/2 is negative, 0 times -1/2, well, it's still 0. 1 times -1/2 is -1/2. 0 times -1/2 is 0. -1 times -1/2 is +1/2. And 0 times -1/2 is 0. So there we have multiplied the Y values by the amplitude. And now all there's left to do, well, not all there's left to do, but all there's left to do for the table is add the vertical shift to the new Y values. Our vertical shift is down 1. I forgot to write in the midline. The midline is Y equals -1. It's the same, it's kind of hard to see that negative. It's the same as the vertical shift. Let's try that again. All right, so we're going to subtract 1 from all these values. Actually, let me move them over a little bit. Because they, whoops, no, not the table. Just wanted to move the ones. Will they move? No. Oh, I hate when that happens. You know what? We'll just rewrite them. That would be so much easier. So sometimes things, if I move it, they get trapped in these cells. So let's subtract 1 from all our amplitude values, and then we'll have our vertical shift. 0 minus 1 is -1. -1/2 plus -1, that's going to be -1.5 or -3/2. 1 minus 0 is -1. 1/2 minus 1, right? So 1/2 minus 1 is just a half, excuse me, a -1/2. And 0 minus 1 is -1. So these are our new Y values. All we have to do is graph those values. But first, we should put we should label our graph, the values on our graph, and then we should also graph the midline. And then we'll graph our points, and we're going to be after we identify domain and range, we'll be done. All right, so we're going up by, so our period is 8 pi. So we need to be able to fit 8 pi in here. Why don't we make every line pi? It's a little easier if I label every other, so this is going to be 2 pi. So every line is pi, which means every other line is 2 pi. So we have, of course this is 0, 2 pi, 4 pi, 6 pi, 8 pi. And instead of labeling the graph on the y-axis by 1, since our largest value here is, well, on the negative side, negative 1/2 is our largest value. All right, and we have some halves there. It would be easier to graph if we made every 2 lines equal 1. We still have enough room to fit our graph. So let's just stretch that out a little bit vertically on that, on the y-axis there, and it'll be a little easier to graph. Right? That's why, because we can kind of play around with how we label the graph here, we do have to make sure if we're comparing graphs that we're looking at the same scale. Otherwise, we have to take that into account. All right, so now let's graph the midline. That's y equals -1. Our graph is going to oscillate around that line there. And now let's graph our points. So we have, and if it helps, I'll write them over here. 0, -1, right there. So it was an x-intercept, now it's just shifted down 1 because our graph is shifted down 1. And then we have 2 pi, -3/2. Right, so that would be right here. And then we have 4 pi, -1. Back up on our midline. And then we have the point 6 pi, -1/2. Our relative maximum. And then finally we have the point 8 pi, -1. Right, now all we need to do is connect. All right, so notice that our graph is a reflection, so usually it goes up and then down. Now it's going down and then up. All right, so we'll connect. And there we go. We'll put arrows to show that the graph is going to do the same thing over and over and over again for all eternity. There's our graph. It's got a new period. It's been reflected. It has an amplitude change, and it has a vertical shift. Domain and range. Right? So, of course, always, always, domain is all real numbers. The range, our low value is -3/2. Our high value is -1/2. So the entire graph fits in between those two y values. And that's it, another one graphed. So in the next Nearpod, we're going to graph 2 more. And that's going to be it really for sine and cosine. So thanks for watching, and bye for now.